Hello and welcome back to the Oxford MAT Livestream. My name's James, great to be with you again. Today on the livestream, Trigonometry. Oh my goodness, good to have you here. So I just said something very shouty in chat in capitals. It's good to have you if you're joining us in live chat. Hi to Harriet, hi to Albers, hi to, I saw you use a 3 blue 1 brown, probably not the real 3 blue 1 brown in chat. Hi Ben, hi Jack. Hi Raphael and Igor and SV I saw earlier on as well. Did I miss anyone? Rabel's here. Hi Rabel. Hi Denim. Oh, hi Elliot and Zach and Ali and Anna. Right, okay, good. Matt and several anonymous people. Oh my goodness. JWC. Good to have everyone here. Right, okay. Trigonometry, all triangles today. I'm going to try not to get too distracted by chat. I've got some admin stuff first to do before we get onto triangles. It's important for me to correct typos and things. I've put a post up in the Slido to say if you've spotted any typos on the flashcards, please let me know, because I spotted a typo on a flashcard, and that means that there's probably more. The typo that I spotted is this one, this card. The polynomial has a root at x over a. I've spelt theorem wrong, so it's not a maths mistake quite. It's a spelling mistake, but you probably expect better from the University of Oxford, so sorry about that one. Other typos, please let me know. That has actually been expanded into, people are putting other comments in chat there as well about other mistakes that I've made in my life. Such as this haircut. Yeah, I've cut my own hair. I rate it 6 out of 10. Would not recommend this barber to anyone else. Speaking of 6 out of 10, let's do the how was your day poll. Other typos are available, says Jack in chat, which is very diplomatically put of you. So as always with the how was your day poll, we're looking for 4 and 5 stars, of course. The 1, 2, 3 stars aim is that we do some sort of maths or something together. We learn about triangles. It's a bit of organised chaos. There was a tweet. We put a tweet out on socials. The social media person picked out one comment from last week. Somebody in chat last week said that it just descended into chaos within 2 hours of mathematics, and that tweet got used on our social media. So there you go. Oh, some people are getting results today, says Ali in chat. That is a week before I expected it, because I thought A-level results day for people in England at least is next week. But I suppose in other parts of the world you might already be getting your A-level results. If you've got your A-level results, then I hope you got everything you dreamed of. I hope that went all right. What's a good score for math papers? Somebody asks. So if you're already trying math papers, then you're ahead of me. I'm not going through any full math papers for a few weeks still. I always say that about 70 is a good score on the math, especially if it's a past paper that you're doing to timed conditions. Of course, you never really know with the past paper because how are you marking it, right? How generous have you decided to be with your long questions? And people are giving today 3.6, which is a little bit lower than last week actually. So I was always hoping to get that a little bit higher on there. I don't know if you're so far as 1 star or 2 star, then perhaps it sounds ridiculous, but it'd be quite nice if a bit of maths was something that you picked up. Yes, we do method marks on the math long questions. For some of the parts of the questions, we do marks for working out. We'll get there. We'll get on a long question later on. Somebody asks my favourite topic is on the mat. It's actually sequences, so we've done it. Sequences and series, I think are just great. Oh no, logarithms. I love logarithms. When are we doing logarithms? A couple of weeks until logarithms. So that will be all right. A-level results so if we're talking about A-level results, they're coming out I think next week for most people, and I guess a couple of weeks for GCSEs. Good, right. John wants to be a professor. Additional training. Pathways in academia are a bit complicated. Normally people do several bits of research in between PhD, things called postdocs, and then eventually get into permanent positions like that after lots of experience. High math scored, low predicted grade. It's a bit of a strange combination. I never say never. You'll notice that over this. Oh, I missed this. Somebody in chat's trying to reply to 3 Blue 1 Brown. Is trigonometry more fundamentally about circles or is it about triangles? Oh my goodness. Can of worms there. I sort of know what they mean by saying it's about circles. Possibly they're thinking about complex numbers, but we're only 5 minutes into the live stream and we need to not get distracted by complex numbers already. And 3 Blue 1 Brown also wants to take MAT a year early. You take the MAT in the year that you apply. So the year that you apply to Oxford for mathematics or computer science, you take the MAT then. You don't take it a year early, you don't take it a year late. It is, I agree with Anonymous here, opinions on gradients. Gradients are the ones with 400 in a circle. I'm never sure if they're sort of a joke or an actual degree-like system. And I agree that it's too hot to be doing maths. Do you want a poll? Jack wants a poll. We'll do a poll. So last week I gave you 3 ways that you might be taking part. You might be doing the live stream. You might be doing the problems live, like me. You might have tried the questions in advance, or you might just be here for the kind of chill. How common are applicants with all 9s at GCSEs? Not common. There should be a Denham's proposed some sort of bingo with complex numbers. I think complex numbers would be like the free square in the middle of the bingo board, like the one that you automatically get, because we always end up talking about complex numbers eventually. Someone's just told me that the gradients are used. I'm reading this out because it's behind the poll. Gradients are used by the French military apparently. I didn't know that fact, so I can't verify that. But that lines up with French inventing the metric system and being very keen on 100s. Rebel says that they're doing the warm-up questions before the live stream as a warm-up, and the MAT questions live. Okay. Last week it took me about an hour to do the warm-up, so we'll see, which felt like quite a long warm-up. It feels like most people are with me doing it live, although shout out to the 18% of people who are doing things in advance and the 15% of people who are just sort of hanging around. I recognise some names from like last year, or people I've seen from Math Club or something, who I reckon have seen some Matt livestream stuff before, which makes me wonder. Maybe there should be an option on the poll like, I did all these questions last year, but here we are. Not organised enough to do things in advance? Well, here we go, because it's a very, very real sense, neither am I. People want to know about GCSEs in chat as well, I guess because GCSE results are coming out as well quite soon, so people are a bit stressed about GCSE results. This year's GCSEs were more or less normal, right? Last year's GCSEs were weird, the year before was weird, so if you're applying now, you did your GCSEs last year and it was, or you didn't do your GCSEs last year and it was weird, and I think we know that, if I can get my counting right. We'll think about it more carefully and not on a live stream. How do I join the Maths Club? The Maths Club is just a website. It's a pretty low bar to joining a Maths Club. It's a website, you can probably find it if you search for Oxford Online Maths Club. It was a live stream that we run. It is a live stream that we run for the first 6 months of each year, where we don't talk about math, we talk about other stuff. Right, I'm going to get this typo off the screen because the typo's been on the screen for a very long time. Let's cut to some maths. Career aspirations in personal statement, absolutely fine. Rafa's been here since episode 007. Episode 007, if you go right back into the archives, I did a really cheesy kind of James Bond style entry, I think. I'm pretty sure I did this. Because it was episode 007, I did sort of James Bond, my name's James, so I did the James Bond entry, and realised that it got obviously 0 reaction because it's a live stream, you can't see anybody having any fun at all. Is it the same format and worksheets every year, asks Zach? Well, it's the same as last year. Same as last year. 2 years ago was a little bit different. The typo was I can't spell the word theorem. Good, okay. Are A-levels given higher priority than international qualifications like Irish Leaving Cert? No, I don't think so. And we've got some equivalences. We think, well, hang on, I shouldn't just say no, I don't think so. I should look up the Irish Leaving Cert, right? We've got some equivalences between different international qualifications, and those are equivalences. I can't remember how that works. Is it obsequious to say that you've been doing? Obsequious isn't. That feels like a word of the day. Hang on, let me just check. Oh my goodness, chat. Obedient or attentive to an excessive or servile degree. Oh, I see, right. You're worried that if you did the maths club for fun, and you had fun, but then you tell the people when you're applying that you had fun in the maths club, that might be, might look like you're trying too hard. I don't know. I think we didn't do it for people to tell us about it in their applications, but if they want to, then go for it. Oh yeah, the super spies. There were super spies in the questions. My name's James. Welcome to the Oxford MAT Livestream. Good, right, okay. Is this good for Tamua? Somebody asked as well. Hopefully, hope so, maths tests. And is this good for STEP? Asks Carsten, more or less. A bit. STEP questions have got way more maths topics. My maths syllabus, maths that you're expected to know, is extremely short. The STEP syllabus is extremely long. I'm already making talking mistakes. Here we go. So he's got Maths Club and Unique on the personal statement. Will other unis hate me? No, other unis will see, oh, this person's doing extra bits of maths. They're thinking about maths already. That's a good thing. And they've got some sort of affiliation to be getting maths from Oxford. That was a secret. Yeah. That was too much. Didn't like that. Right, cool. I'm going to switch that off and switch this on, and we're going to talk about trigonometry. Right, let's go. There's a lot hidden in here, actually, in this math syllabus. I want to point at things quickly. The syllabus has got solution of simple trigonometric equations. Now, what on earth is a trigonometric equation? We're going to get down to some of those later on. I've got some examples in the warm-up and then an example from a math question. The best way to understand it is to just sort of see some equations with trigonometric functions in them and practice solving them. So that's something we can do. There are some identities which, if you've never seen these before, then hey, this is a bit of a weird way to learn these, but hey, there's something called tan, which is sine divided by cos. Sine squared plus cos squared is 1. That's a brilliant relationship. And sine and cosine related together, they're sort of extremely similar functions. Sine of 90 minus x is cosine. And also, this does follow from the one on the board, but just to be really clear here, cosine of 90 degrees minus x is equal to sine of x. That's gone slightly behind chat. Whose chat message? There we go. SV finds STEP questions more rewarding than maths. I think they're more involved. They've sometimes got more stuff going on within a math question. They're worth 20 marks, not 15, but what's a mark, you know? I think there's a definition that tan x is sine over cosine, for me, anyway. That's how I would define tan x. If not, then I don't really know where you're starting. Okay, so side note, but depends where you start. For me, that feels like a sensible place to start as a definition. If you define things in terms of triangles, like down here on the board, then it just all makes sense that tan is sine over cosine, kind of by definition. These things divide like that. If you define everything in terms of power series, which is how people do it at university, then I guess it's a bit more complicated. But everything's a bit more complicated by that stage. Do you need to know all the trig identities? No, so there are other trig identities that you maybe learn in A-level that are not on this map syllabus. So not on this syllabus, are things like cos of 2x, or cos of a plus b, or sine of a plus b, or sine of a minus b, or that thing about combining cos a, cos b into things that look like cos a plus b and cos a minus b over 2. Yeah, you see, this is a problem. Somebody's put, sorry, what's a power series in chat, and let's put this not on the syllabus, like power series. I got distracted a bit because somebody asked about definitions, and at university you might define something like these things in terms of their power series. The power series look like 1 minus x squared over 2 plus x to the 4 over 24. Not on syllabus, don't worry about it. But you asked, so we've got to go. This is the difference between the difference between Maths Club and the Math Livestreams is very subtle. The Maths Club, it's okay for me to get distracted and just tell you about power series, whereas Math Livestream, I've got to be very focused on the math syllabus. For example, when Mames Junro in chat says, is that identity theft? No, it's identity theft. Is knowledge of radians assumed? No. We now don't assume knowledge of radians. We used to before 2018, but then the syllabus for the A-level changed. We no longer assume you know about radians. So we ask all the questions in degrees. You are allowed to use radians if you want to when you're answering the questions. We all know about radians. We also know about gradients. You can convert things if you like, but the questions are going to be written in terms of degrees, like how this is as 90 degrees up here on the board. Okay, good. People are going for complex numbers in chat because we're talking about whatever we're talking about. What happened there was I just got distracted by the text. James focused the random tangents to the best part. That comment about me being distracted easily distracted me. Good. Okay, more complex number chat in there and comparison of Matt and Step. Good. Okay. So I put some revision notes together. I'm not really sure if these are A-level or GCSE really. Pythagoras is pretty good, right? Love a good bit of Pythagoras, relating together side lengths of the sides here. You also know the cosine rule, which I've got coming up in a second. Because you know the cosine rule, you know that Pythagoras' theorem is sort of a special case of the cosine rule. The cosine rule says something like c squared is a squared plus b squared minus 2ab cos theta. So if cos theta is 0 for 90 degrees, then this is Pythag. But maybe that's all obvious, who knows. Is it worth knowing geometric proofs of the sine rule and cosine rule? I think not really, but I'm not going to ban you from knowing them. I think it's good to know where things come from, just generally in life. But you know, I think it would be hard to write a math question which assumed that everyone was on the same page about what that proof is. Good. Right. Okay. Right. Good. Okay. I'm going to get distracted by one thing because chat says MATLAB or LaTeX. Obviously both. Both all the time, constantly. Both open. Tabs. Just go for both. Right, good. Those are two computer programs that I use for doing lots of things. Right, good. Okay. Periodicity. You can combine facts together. So this is a little bit tricky, I suppose. But somebody in chat earlier said something like, why, and this is a good question, why is cosine of 180 degrees minus x equals a cosine of x? Or is it minus cosine of x? Excuse me, what I think. Minus cosine of x. Let's tidy that up slightly. So hard thinking and being correct all at the same time. I don't know how anybody does it. Right, minus cosine of x. And I can think of a couple of ways to make progress with that, but I think I want to give it to chat as well. Latex or papers? It's not going to be a vote, is it? It's not going to be a vote. Yeah, so Nikita wants to use the addition formulae, which you already said that I wasn't so keen on using the addition formulae because they're not on the math syllabus. I wonder if we can convince this person in chat that these things are equal, only using facts that we've just been talking about. I want to use the 90 minus fact, I think. Yeah, I think I want to use the 90 minus that fact. Oh, cast and graph transformations. Right, okay, these are good, these are good. Oh, chat's got off and away, sorry. I asked the question and forgot I'd asked. Oh my goodness, use the graph, think about graphical translations. Oh yeah, okay, and then there's an algebraic one in there as well. People like graphs? People like graphs? Unit circles, cast. So cast is that rule where you think about whether things are positive or negative by having this handy diagram which tells you whether things are positive or negative. So between 0 and 90 degrees, cos is positive. Over here, only sine is. Over here, only tan is. And then the A is for all of them, I think. I'm not very good at remembering mnemonics like that, I think. I like the graph translations, I do like. People have got different mnemonics for that one. Oh, is that wrong? Oh, because it's not clockwise. Is it actually this one? Oh, that's bizarre. It's that one, isn't it? That diagram was wrong. It's because I don't use this. Oh, is it actually like that? Okay, people who use this acronym, you've got to remember to write it left to right rather than writing it clockwise. Yeah, all is the first comment. I knew as I was labelling it, I knew something had gone terribly wrong. This is the real way to get chat engagement, right? James, that is so not right. The real way to get chat engagement is to do something wrong. But then it says cats if you read it anti-clockwise. Right, I'm never attempting to remember this again. I like the algebraic method that people were putting in chat as well. I have a slightly different approach, I suppose, which is to do something like this, to write it as cosine of 90 minus x minus 90. I think that's true. I think that's equal. These things are clearly equal. Because inside it's like 90 take away x, then plus another 90. But then I'm going to use the cosine of negative, the cosine of 90 minus thing rule to say that that's equal to sine of x minus 90. And then I'm going to use the sine of, I guess I'm using sine of negative x is negative sine of x here, and then flip that around again using the 90 minus rule. So I think I've used two facts here, or three. I've used this fact. It is so warm in here. Cos x, and I've also used the sine of x equals minus sine of minus x rule. If any of those are a surprise to you, then there are some flashcards that you might like. People in chat are still posting chat things about how I can't do cast. I was right in it. Oh my goodness. Left to right? Oh my goodness. I'm still wrong. I still can't get this right. Oh, I see. So I'm completely wrong. My goodness. Harriet. While I was writing, Harriet put a chat comment that is exactly what I was writing, but with a question mark at the end, which, I don't know. You don't need the question mark. Right, okay. All students trust Cambridge. Okay. But am I going clockwise or am I going left, right? Top left clockwise, SAC. These acronyms are mad. I'm not enjoying this. No, because they're all positive to start off with, right? Yeah, I've outraged. Everything's gone very wrong. Reg, what if there's nothing rare about this? Anti-clockwise. Oh no, I can't even get clocks right. How long are we? Oh, we're 20 minutes in. I can't just ditch it now. Right. Good. Focus. We've proved that cosine of 180 minus x is equal to minus cosine x, which is a question in chat. People talking about the diagrams. I really like that as well. I'm going to quickly draw some diagrams. I don't think the diagrams are super convincing, if I'm honest, partly because it's me drawing them. So that's cosine of x, where this is 180 degrees. Because what I'm going to draw is something like this, and say you start out going this way, you go 1 and down, whereas if you start from 180, you go left, then it's 180 minus x, and you're going from -1 and upwards. The graph looks like this, and that's why it's negative cosine of x. And the cast stuff reminds you which things are negative or not, but they just tell you why. It doesn't quite prove to me that the things are equal. It shows me that one of them's positive, the other one's negative. Okay, fine. Are they equal to negative each other? Good. Yeah, Leonard Euler, Euler, my man. I'll take this. Proof that acronyms don't help. Is proof that acronyms don't help? Oh, that would be great. Can we make that be an anagram to remind us of something else? So we've got PADH. Proof that acronyms don't help. That's the homework challenge. Nikki just got 2 ice creams. I'm jealous. Good. Okay. There's a bit here. Oh my goodness, what a typo. What an awful typo. Don't look at that. It's probably wrong on everywhere. So this is the area of the triangle. There's this rule that it's half AB sine angle in between the sides. It's worth having a kind of mental image, I think, to have something like some idea about you're taking two sides of the triangle, AB, and the angle in between. Sine of the angle in between. It's worth having a mental image like that of how the things relate together, because you need to be able to do this even if they're not labelled A, B, and C, alpha, beta, gamma, and also other ways round, if you can remember the picture. You've got kind of 2 clock hands and the angle in between. And you can use those facts to work out the area of the triangle. Good. Okay. Unit circle is also good, I think, but I have moved on. Yeah, the angle between those 2 lines, good. There's a proof of the sine rule in the warm-up where you take these 3 expressions with alpha instead of alpha. You take these 3 expressions and you divide them all by A, B, C and multiply them all by 2. So if you multiply them all by 2, you get this. If you then divide them all by A, B, C, you get sine gamma over C equals sine alpha over A equals sine beta over b divided by ABC. All three of them. That's called the sine rule. It says that the sines of the angles in a triangle are related together if you allow for the side lengths as well. And these say something like the sine of the angle related to the opposite side is the same for each way round the triangle is. How do you misspell a letter? Yeah, I know. The answer is LaTeX, which is the typesetting tool I use, which, you know. Life is pain. There's the cosine rule. We mentioned it before. You should know the cosine rule. You should be ready to apply the cosine rule in situations where you know two of the sides of a triangle and an angle, and you want to find the other side. Here I've stated it with A, B, and C that way around, but you can obviously do appropriate permutations of the letters, or just apply it to any random triangle you see. So that'd be pretty good. What's Lanny's theorem? Can you help me out? Life is pain. Rates day 3 stars. Refuses to elaborate. Yeah, there we go. I love this account. This account is just going to plague me around, follow me around, isn't it? This is the LaTeX I presumably typed, or maybe without the slash, or maybe with the slash. Okay, right, good. Right, typesetting banter aside, I think it's time for the warm-up. Warm-up. Some people said they did the warm-up before we went live, so we'll have a go. At speed running through this, I'm going to cheekily not do the hardest bit of the warm-up because it's too much writing for me. But if you're watching at home, then I honestly think this is the exercise that you should try. Probably, what I'm thinking is probably your teachers are too nice to make you do this. Like from memory, just go. Just please tell me all the values of sine, cosine, tan. These are basically all the values of sine, cosine, and tan that you could possibly be expected to know off the top of your head, I think. There's about 18 things on the board, right? Please just give me all 18 times 3 values of those things, 54 of those. There are no small angle approximations on the MAT syllabus. How quickly should this be? You should be able to sort of write it out, I think. Being careful as you write it out. But ideally, at least the first bit, sine of 0 is 0, sine of 30 is 1/2, sine of root 45 is root 2 over 2, sine of 60 is root 3 over 2, sine of 90 is 1, and then it goes back down again. So now using that, I can fill in the rest of that. I know how it rises and then how it falls going back down again. It's probably the easiest bit. Some people are saying that maybe their teachers did make them do this, which is good. If anybody's using, by the way, if anybody's using the root 4 over 2 mnemonic, I'm not really a fan of the root 4 over 2 mnemonic. I mean, it gives you the right answer. It gives you the number 1, but it just feels slightly slow to me to have a mnemonic where you write down square root of 4 over 2 and then you rearrange it and you simplify it down to the number 1. So if your current method is to remember that it's root 1, root 2, root 3, root 4 over 2, which I've seen people do, then I think your special task for you over the summer is to get to the point where you can write that down without relying on writing down root 4 over 2. I just think it's slightly faster. This is absolutely the MAT Livestream in just one quote. Any free resources to practice trig? Well, so the rest of the warm-up goes like this. Yeah, so in a vacuum, if we saw cos 315, I would do it slowly. Actually, I would probably do it as work, and somehow filling in the table is a little bit better. Graph or the cast diagram, the infamous now cast diagram. Right, okay. I'm going to stop there. Yeah, so pulling out 315 or something is a little bit tough, isn't it? So I can sort of see that looks a bit 45-ish, but then I'm going to have to concentrate, I think, to realise that sine of 360 is 0, so this is coming up to 360 probably. So it's probably minus root 2 over 2, but I had to think quite a lot there. I didn't just know it. Probably behind the scenes, my brain's using some of these facts. Is it okay to leave final fractions with square roots in the denominator? Yeah, I think that's all right, unless they ask you. Oh, Matt Parker's also criticised that mnemonic recently. Proof that anything I say, Matt Parker has already said better. Good. Apply to Oxford with Australian qualifications. Please check the international qualifications page. We're looking for a particular score in ATAR as well as regional I can't remember what it's called, but regional high school certificates. Right, okay. Solutions to sine x equals 1/2. You should be able to do this by imagining sine x, being really careful about the range. Where's that equal to 1/2? Well, I'm expecting a couple of solutions between 0 and 360 degrees. And if I really concentrate, I can remember that they are from my table above 30 degrees and 150 degrees. Chat will tell me if I'm wrong. That is the beauty of chat. Where's tan x equal to 1? Well, hang on, tan x equal to 1 is something that happens in this triangle. So I know that it happens when x is 45 degrees. And I think it also happens because tan is periodic. With period 180 degrees, I suppose it also happens when x is 225 degrees. Now this is a setup for a kind of trap question where we're asked for the solutions to tan 45x equals 1, and we're given the same range on x. We're told that x is between 0 and 360 degrees, so it's very tempting to just take those previous solutions that we had and divide through by 45. So before, we saw that x is equal to 45 or 225. Now, we might think that 45x is equal to 45 or 225 and just divide, but actually there are other possibilities. So let's see. Yeah, so in fact, the solutions before, the reason in the previous question we stopped writing our solutions was because these were the things between 0 and 360 degrees. If not, we'd have kept going. We'd have kept going. We'd have written 225 plus 180, or 225 plus 360. You know, to keep adding on 180s. In the previous question 3 up here, we had this restriction that x had to be between 0 and 360. That's no longer the restriction that we've got, which means that we can keep going. So make it this or this, because we just need x to be between 0 and 360 degrees. So 45x can be really big. Said differently, these are two solutions that are in the range, but there's also these solutions like this, or what are these? These are 4n plus 1 or something, for n is equal to 0, 1, 2, up to, oh goodness, quite large. I want it to get up to 360, so I want to put in 89 in here. 89 maybe? Sounds about right. 90 possibilities, sounds about right. 9 solutions, yeah, sounds good. Yeah, so making a substitution to start off with would be really good. If you make the substitution, don't forget to change the inequality like Tom has done here in chat. That 45x 45x isn't restricted between 0 and 360 degrees. 45x can be quite a lot bigger. I'm taking it on trust that Tom has multiplied 360 by 45 correctly. Don't let me down here, Tom. Good. This one is foreshadowing, so question 5 is foreshadowing for a later question, and so I added this one for this year. If you're playing along from last year as well for some reason, then hey, here's a new question. It's not just the same thing again. What I wanted you to do here was to square, of course, and then to realise, you've got cos squared and sine squared in there. So hopefully we can swap this sine squared plus cos squared. It's 1 plus 2 cos x sine x. And I've used this slightly strange language that I'd like you to write that in terms of the variable u, which is defined to be cos x sine x, which is fine in the end because we just write 1 plus 2u. But I wanted to use this slightly strange language, like in terms of the variable u, where I define a new variable as well, because I think you need to see that kind of weird, slightly strange language about changing variable, about having variables. No roots of unity in MAT syllabus because there are no complex numbers in the MAT syllabus, despite how much we talk about them. And no complex numbers on MAT, so no roots of unity. Somebody in chat saying, oh, what's a root of unity, James? Yeah, so there's a tempting sort of side thing as well that's caught SV out a little bit, that this thing is related to sine of 2x, but that's not on the MAT syllabus. Okay, so not MAT, u is equal to sine of 2x divided by 2, which maybe gives you an alternative way to do the question, but I'm not quite sure. I mean, it sort of does, I think. There's also a way to rewrite the stuff inside the bracket, to rewrite the stuff inside the bracket in terms of cos of x minus pi over 4 or something like that. Thanks everyone. So roots of unity. Look, we're going fast. We're going faster than last week. We're going to do a very quick side. Okay. So roots of unity are solutions to equations like x cubed equals 1. Now you're probably thinking already, I know the solutions to x cubed equals 1. That's just x is 1. But if you use complex numbers are numbers like this where I squared is minus 1. If you use complex numbers, there are other solutions. The other solutions are minus 1/2 plus or minus root 3 over 2 times I, where I is the number that squares to minus 1. If you don't believe me, then please go and check that if you take that number and you square it, so I get the first term squared, I get the last term squared, and I get 2 times the cross term squared, which is not going to turn out to be 1 at all, is it? 2 times the product of the cross term. What have I done wrong? It's probably the talking and the writing at the same time. I'm cubing it. I'm supposed to be cubing it. Which I'm not going to do live. There we go. If you don't believe me, go and cube that number very carefully. You might think, aha, these numbers remind me of something, and you'd be right. These are the numbers that we just had earlier on, all these 1/2 and root 3s of 2. In the kind of Argand diagram, where you have the real part over here and the imaginary part of your number up here, the number 1, the real numbers live over here, but the number minus 1/2 plus root 3 over 2 lives kind of over here. And the number minus 1/2 minus root 3 over 2 lies over here. These numbers lie on a equilateral triangle, and that's not a coincidence. So because it's an equilateral triangle, there are some good angles going on, the same angles that we've had before. If you're interested in this, then go and look up roots of unity. There are some good resources online to tell you more. They are a very interesting thing. As a kind of advert for what you'll learn is that the solutions to x to the 5 equals 1 lie on a regular pentagon. Which is quite cool. And actually this is the best way I know of describing where the corners of a pentagon are, is to say, well, solve this equation, whatever it means to solve this equation, and then just there are the points. Good. Do you need to know how to solve transcendental equations? Definitely not. No. Matt live viewers go, one stream without mentioning I, challenge, brackets, impossible, close brackets. Good. Yep. Did I use your formula last week? Who are you? Gauss. Can't remember. Man with 1,000 tangents. Cannot remember how to CAST. Good. Okay, that was a good tangent. I liked that one. Can we stay on target? Can we stay on track? No, complex numbers are just too interesting. Is it n-sided polygons for x to the n equals 1? Yes, it is. They're so good. I love a good pattern. Oh look, a crossover question. Good. Crossover question, because this is slightly related to geometric series, isn't it? This is a geometric series. It's got first term 1, and it's got common ratio minus sine squared x. So because minus sine squared and then multiply by minus sine squared again. So this is the infinite sum here is 1 over 1 plus sine squared x. That's pretty good, I think. 1 minus 1 over a over 1 minus r, right? Yeah. You need mod r to be less than 1, so you need to not have 90 degrees itself in there. The I challenge is to go an entire live stream without mentioning I. It's impossible. We always mention the complex number I. I do feel absolutely very, some people have probably learnt complex numbers from just random tangents that we've done on Maths Club and we've done on this stream so far. If you've learnt about complex numbers from just my random tangents, then I'm really sorry. That's probably not a good way. Right, good. Okay. A over 1 minus r. Yes, Ben B. Oh, you try pairing terms. Oh, I see. Ooh, single expression. Yeah, maybe I caught you out a bit, sorry. Transferable skills from previous things. Why not infinite sum? Oh, right, because I didn't want you to write it as an infinite sum, because it's already written as an infinite sum. if I let you write it, what do I mean? And what's a better way to say this, right? Question writing skills, right? I want you to write it down as an expression. It's already an expression. Okay, good. You should see, if you want to see me in a panic, you should see last year's live stream where we tried to do all of this in 1 hour, but with just as many tangents. Could we put a minus sign in instead? Oh, change it to minus, not in sigma notation or something. Don't know what that means, sorry. Hey, facts about transcendental equations. Did somebody ask in chat and I missed it? It's probably good. Avoid a tangent. Okay, good. Oh, and there's the Adrian's gone for it. Golf clap. Right. Okay. Oh, it's a dash, not a minus sign. Ah. Could you change it to not in? Oh yeah, right. Okay. Boom. That was a dash, not a minus sign. We're doing great. Okay. Shouldn't have said infinite sum, it just got more confusing. Yeah, okay, right. Okay, so if I delete this bracket, it's not helping, right? Single expression is doing enough work. This is doing enough work. Let's get this smiley face and star. Delete the other thing in brackets. Right, okay. Join us next year. Slightly improved. Ah, here's a trick. Here's a trick. I like this. I like this. 1 minus sine x. Yeah. You can pair the terms together. Pairing the terms together is pretty fun because this first pair is cos squared, and then this second pair is sine to the 4 times cos squared. So then you can pull out the cos squared and do a sum on sine to the 4 as a geometric series, I think. Is that true? Yeah, I think that's true. So you can pull out the factor of cos squared and then write, so it turns out to be cos squared x, that term's in all of my, that term's everywhere, times 1 over, and the common ratio is now sine to the 4. And then these things are actually equal because on the bottom there, by the difference of two squares, that's 1 minus sine squared x, 1 plus sine squared x. And the cos squared on the top is equal to 1 minus sine squared x. So it cancels, and you get 1 over 1 plus sine squared, which is the same. So it's a different approach, same thing. Q on the Q&A. Make a Q for the Q&A, but don't use the ladder used for convex numbers. Oh, right, I see what Ben's done. I should not have read that, that was 2. Yeah, the one with actual tangents is actually you can't see because YouTube hide the dislikes, but the Oxford Online Math Club episode with tangents is the least popular one ever. I don't know what it was about it. Anyway, YouTube's weird. Right, cool. We're writing this in terms of sine. Let's go for it. So this is 1 minus sine squared plus 1 minus sine squared. Looks good. I might stop there. It's quite lazy of me, but it's hot today. I've said I would stop and I kept going. Don't know what's wrong with me. There we go. Looking even better. I'm going to even group the terms together. Sorry for the handwriting, it's got worse. I don't know something might be wrong with the tablet or something. We've got a simplification challenge, which is to do something like, I think I'm going to do the sort of trick that I was doing before, to write that as x 90 minus, what's this number going to be? 360, I think. Right? Because 360 plus 90 is 450, so I'm allowed to do this. But also I know a fact about this, that this is sine of x minus 360 degrees. So I guess that's sine x. Chat will tell me if I'm wrong. I don't know what Renaissance Technologies is, and I don't know who this person is. I think I'm being asked for opinions, or ops. What if x equals pi? Somewhere else. Okay, good. Oh, extra sine squareds or something. Good. Yeah, periodicity of cos. That would maybe have been faster to say that this is cos of 360 degrees plus 90 minus x. Yeah, I prefer that, I think. Good strategy, I like it. Yeah, it's a couple of lines less work, isn't it? I feel more like I've got to the right answer. I've got to the same answer that I got to before. And I wrote this question, so I should know the answer. But somehow. Oh, did I write -2 instead of -4? No. It just goes to show, doesn't it? Don't try and simplify your work. Don't try and multiply things out. Should have just abandoned it. Should have just left it alone. I've learnt my lesson. Don't do work. Oh, it's a mathematician. Okay, I need to go and learn about mathematician. Nikita is having a go at this double angle-y thing. Oh yeah, Tom, don't take it personally. It was the one you asked me to do on the show, but it's also my idea. If anyone from Oxford watches these, you'll lose your job. That does sound true, doesn't it? Luckily, none of my colleagues ever watch these, so I can make all the mistakes that I need to. I get all of the mistakes out of my system on you lot, and then in my actual job, I never make any mistakes at all. So that's the pro move. In the actual exam, I think you're actually allowed to use facts that you know, provided the question doesn't tell you not to. So I've added the word here. If you know a fact about sine A minus B, then go wild in the exam, I say. Go for it, use that fact. I'm not going to simplify it here because it's a whole bunch of the things we've just been doing, and it turns out to be cos squared plus sine squared is 1. So good warm-up exercise. I'm already feeling nice and warm, so I'm skipping it. Similarly over here, this is really just a syllabus tester for a sort of thing to test whether you can do the stuff in the syllabus, to say, if I show you this triangle with AB is 2, BC is 3, and the angle of ABC is 120 degrees, can you find the remaining side length AC, which you should be able to do with the cosine rule, the area of the triangle using the sine rule, and then slightly tricky, expression for sine BCA using, it's not the sine rule, it's just the area rule, and then an expression for sine BCA, that's the sine rule. Good, okay. There's a thing about the cosine rule and the triangular identity at the bottom, but I think it's not so much warm-up as it is just doing some stuff. So I think we should get going. Has anybody ever asked me for a selfie? Yeah. That has happened. The very first time that happened, somebody came up to me with their phone and they said, my maths teacher is a big fan of the show. Can I take a photo for my maths teacher? And they took a selfie for their maths teacher. It was very cute. Right, you should do a collab with Tom Crawford, says someone in chat. Let's wait for that to load in chat. It's for Gauss. Gauss, season 2, episode 7 of the Maths Club. We did an interview question with Tom. Oh, and Westminster visited an event and we did a whole bunch of selfies. It was weird. I've also now signed somebody's calculator. There's someone out there whose calculator is signed by me, which I did not know was a thing. Good, right, okay. Here's a math question. It's Math 2017, question 1b. We're looking for the minimum value of this function. We're going to do this question a couple of different ways. I'm going to switch poll on so that you can see the poll. And have a vote. Oh, that has not worked. Let me reset that. Lazily reusing polls from before. So I need to, there we go. But with different names. Good, okay, let's hide results as well. That'd be more fun. Good. Okay. Was I at the Oxford Open Day? Yeah, I did some of the talks, hosted some stuff. Right, good, okay. Okay, right, question. We're going to do this a couple of different ways because I think people have probably got different strategies. The quickest way I can think of to get into this is to spot that it looks a bit like a quadratic. It's not quite a quadratic equation, is it? So quadratic would be if it was 9x squared minus 12x plus 7. I mean, it's not that. But we could deal with it if it was. If it was that, then we could do some stuff like, I don't know, completing the square or maybe differentiating it to find the minimum. In fact, I think I might try and do that anyway, right? But instead of x, I'm going to use, where I want an x squared, it says cos to the 4, so I'm going to use cos squared instead of x. And I'm going to try and complete the square anyway. So completing the square gives me something like this. We'll get onto a later episode about skills using quadratics, I suppose. Something that I previously jokingly referred to as quadratic science. But what we're doing here is trying to just complete the square using the fact, even though it's not quite a quadratic, it's a quadratic of cos squared x. To be able to manipulate that, I'm concentrating really hard so that I can factorise this quadratic. I think it's worked. Has it worked? Tell me it's worked. Good. I'm completing the square. Someone in chat very excited about completing the square or making a change of variables if you like. So if you want to write what am I going to write? U equals cos squared x might be good. I've stolen that from the chat. How to complete the square. Later episode on completing the square. What I've done is I've written down, I want to get it in this format, and I'm really good at multiplying stuff like this out. So as I'm writing, I'm trying to think about what would happen if I multiplied it out. I can't remember any formulas for this or any mnemonics or anything. But as I write it down, I'm trying to remember that it's 3 cos squared x here. When that squares, that'll give me the 9 cos to the 4. Minus 2 I've put here. I'm concentrating quite hard for that bit because I'm trying to remember that when I multiply it out, I'll cross multiply and I'll get an extra factor of 2. So that'd be, instead of minus 6 cos squared x, I'll get minus 12 cos squared x. So that's kind of like divided by 2 in my head. So I divide this by that and then by 2 as well. But I don't really think about it like that. I think about imagining what will happen when I multiply out. As a consequence of that, when I multiply this square, I'll get minus 2 squared, which is 4. I don't want 4, I want 7, so I need to add on another 3 as well on the end. That's more or less exactly what's going through my head when I complete the square. I'm a little bit nervous because I think this might turn out to be an answer. Yes, okay, good. Okay, I'm going to have a quick look at the poll. How's the poll going? The poll's going okay. There are two options that I quite like at the moment that are doing quite well. I'll quickly have a quick look at the poll. Here's the poll at the moment. The poll at the moment is quite solidly on A, but B is a little bit popular as well, and D and E have got a couple of votes. Now that I've put it off so people can see people's votes are changing, that's the crowd. Because I suppose maybe people are thinking about what happens when yeah, I can see. So maybe people are thinking about making cos squared equal to 1. If you make cos squared equal to 1, then you get no, you don't. You get 3 minus 2, which is 1 squared, and you add it to the 3 and you get 4. But actually, if you make cos squared equal to 0, you can make this thing smaller. You'll get 0 minus 2 is squared. No, that's terrible. That's disaster, because then you get 7. You get 7. That's a disaster. So over here, cos squared 1, you get 4. I see. So maybe people have tried both of those and got down to those two possibilities and said, well, 4 is less than 7, so I'm picking 4. More people are now moving their vote onto E, which is interesting. Or is that C? Oh no, C and E are both doing slightly okay. Not a huge number of votes, so I might leave that alone for a second and catch up with chat. Yep, okay. I suppose the strategy that I like is to say, well, there's no reason that cos squared has to be a nice number at the minimum. All I know about finding minimums of functions is to say, well, this now, if I squinted it, it looks like things squared plus 3. This thing in the pink box, well, it's a square of something, so it's positive or it's 0. Can I make this 0? I haven't made it 0 so far by plugging in cos squared as 1 or cos squared as 0. I haven't made it 0 so far, but maybe if I tried, I could make it equal to 0. If I can, then I'm done, because I'll get 0 for the pink box and then add on this 3 at the end, and the minimum will be 3. I suppose at that stage I know I'm done because of maths, and also because once I've found that it can be 3, there are no smaller options on the multiple choice, so I'm probably done. That's a bit of a cheeky approach. Anyway, short answer, I can make this equal to 0. If I make this, so if I make cos squared x equal to 2/3, so if I choose cosine to be root 2 over 3, which it does do. Not a very nice number. I don't know what angle that is. It's not one of the nice ones from the table before. But hey, that does exist. This is between 0 and 1. There is some number that x that satisfies that. And at that point, the value of the pink square will be 0. So the f of x will be 3 overall. The answer is A. Weird. Did I mean cos squared x equals 2 over 3? Maybe I did. Good. 2/3. Make Yeah, make it 2/3. Good. Okay, good. Let's stop the poll. Ha, stop. Yeah, so I wanted to show you some other methods as well. Let's save. I'm going to save that one. Okay, show you some other methods quickly. So something you could think about doing is think about the graph of this function. Being able to graph this function is a little bit tricky, especially because it's quite a complicated function. Here's a Desmos thing that I built. So this Desmos thing is supposed to help us understand these functions. On the left here I've got a quadratic, and the quadratic is being applied to, at the moment, sine of x. And there's different things that can happen depending on what the quadratic's doing. You can get cases like this, which is actually the case that we're in, where there's some wibbly wobbly stuff going on like that. It has maxima and minima, and also this weird local maxima in between. You can have that the other way up, and you can have stuff going on in between. Our function is actually slightly different in that it's sine squared rather than, it's a function of, I suppose it's a function of cos squared, isn't it? Let's put cos in there as well, that'll make people happier. A function of cos squared, but same sort of idea, that you can have things that have just maxima and minima, or some things that have local maxima and local minima going on as well. So it's worth building something like this, just having a play around with it to find out these kind of weird things that can happen when you apply a quadratic to a function like cosine or cosine squared. It's pretty similar when you apply quadratic to cosine or cosine squared, because cosine and cosine squared are actually quite similar things. Tangent for another day, I think. Yeah, it turned it into quadratic and differentiated it. So if you just turn it into a quadratic like this, 9u squared minus 12u plus 7, and just differentiate that, then you get 18u minus 12. So your minimum happens at u is equal to, oh gosh, 2/3. Fair enough. You should technically probably check that the minimum does actually meet that, does actually do that, which is, it does, because cosine squared x can be 2/3. And technically you are missing some turning points. This will only find you the turning points at the extrema. It won't find the kind of in-between turning points. This won't identify these extremal values of 4 and 7 out of there. You've kind of technically lost them. Being able to differentiate this function is actually surprisingly difficult, I think. If you know the chain rule, then you'll know that there's some extra stuff going on when you want to differentiate a function of a function. If you don't know the chain rule, don't worry about it. You're going to learn the chain rule quite soon, probably, and then you'll be able to differentiate this function if you want to. Yeah, so my other method was going to be, let's just differentiate it and see what happens. I'm not sure that's very useful. This is strictly not maths, right? In that this would not be an okay math question. But if you want to just differentiate it, I mean, it's a multiple choice question, so anything goes. Then you'd get something like 36 times negative sine x cos cubed x minus 24 cos x. Cos x differentiates to minus sine x. That would be 0. So you have these solutions at either sine x equals 0 or at cos squared x equals 2/3. And then you discover that at those ones, the value, the ones on the left, the value is either 4 or 7, and the ones on the right, the value is 3. There we go. So yeah, it's quite a complicated graph, isn't it? I have read bits of Go to Leisure Park. Good, right. Complicated graph, complicated function, but just turning it into quadratic and thinking carefully about it. I like thinking about this function in the pink box, just thinking very slowly, one step at a time. I've shown you several different methods, but the actual thing that I think you need to think for this question is not that bad. Mathematicians can't read, don't be silly. Right, okay, let's do the philosophy question, because you've asked it a few times. Not that I'm encouraging people to ask their questions multiple times to try and get them answered live, but here we go. Is maths and philosophy a good preparation for doing a master's in maths and foundations of computer science? I actually don't know is the problem. I think probably you'd want some sort of underpinning knowledge of computer science in order to do that particular master's course. But it's probably a good idea to check the requirements on the master's course admissions page. I'd be a bit surprised in a way if it was good preparation, because there isn't very much computer science in the maths and philosophy course. It's a tiny bit. If you take an optional unit, you could do some computer science, but not a lot. Cool, right, good. Watching the replay of this, I've realised that I say cool, right, good way too much. It's basically punctuation for me. Cool, right, good. MAT 2016, question 1D. Here's another MAT question. Are we ready? I think we're ready. If I reset the votes, have I done the setup that I should have done? Yes, right. Cool. It's a question about looking for solutions to a particular equation. The trick again is going to be to take this quite scary equation and to turn it into a more familiar equation. The second term there is the square of the first term, is the hint for the worksheet here. I'd like to know how many solutions that's got in a particular range. Now this thing about counting solutions, we've got to be careful. Remember that warm-up question where we had something that was 45 times x, and we had to be careful with the ranges. Here it doesn't look like we're going to be tricked, because the functions are functions of x in the question, and the range is defined on x. So I'm not nervous at the moment, but let's keep an eye on that being the range for x as we go through. Good. Right, good. Okay, shall I turn a poll on? That's because the admissions requirements for MPhOS, mathematical focused computer science, say mathematically focused. Maths and philosophy maybe is mathematically focused. I mean, it is a bit, isn't it? Maybe it's possible. I'm not sure. I'll have to find out. Sorry. I don't really work on masters courses. So yeah, good. Right, okay, we're doing a MAT question. It's happening. There's a poll up. We're live. Anything could happen. Goodness me. And the votes are hidden, that's why nothing's happening. Which colleges are good for maths? Somebody's asking in chat behind the scenes. I might let chat answer that one. You probably know my standard answer already if you've seen me talk about colleges before at an open day or something. And it just amuses me if people have learnt stuff. Right. No, actually, let's go for it. So there are 29 colleges that take mathematicians. They're all great. They all have the same mathematics teaching because they all go to the same maths lectures and the same maths content, do the same maths exams at the end. Shortlisting after the MAT is a different question, so we've asked. They use information from your application form, your past exam results a bit, and predicted grades a bit. But they also look at the MAT score. Do say we've got all these great applicants. Look at the MAT scores to help us decide who we're going to shortlist. Somebody says it's their first time here. Hi, nice to see you. What kind of predicted grades? We've got a very specific conditional offer. Yeah, A star AA is the conditional offer for maths and computer science, I think. The average grades of accepted applicants is something quite different. Is something different, but that doesn't mean that the conditional offer is not what it is. The conditional offer is what the conditional offer is. Yeah, okay, right. Question. Let's go. So people having a go at that. I sort of want to turn it off to just have chat going, but nah, we'll leave it. Can I flip it over here? No, I cannot. Right, good. Behind the poll, Rabelais, I want to give you credit, so I'm going to switch it off very briefly. I said just plugging in n equals 1 and n equals 2 gives you the answer straight away, which I like. That's got 2 thumbs ups, and I think maybe it deserves more than 2 thumbs up, because these kind of strategies where you plug in numbers and you get solutions are good. I like them. Sometimes they let you go through this kind of faster strategy. Cartan's got a suggestion to do this algebraically though, where we take out a common factor. And we write that as cosine to the power of n x, 1 plus cosine to the power of n x. And then that sort of factorised it in a way, so we either want cosine x to be equal to 0 or cosine to the power of nx to be equal to -1. Okay, so we've now got 2 separate cases. In the first one, cosine x is 0. I know when that happens at a couple of different numbers. Maybe I should write them down, just be careful. It happens when x is 90 degrees or when x is 270 degrees. And on the right here we've got cos to the n x equals -1. So that would mean something like, I suppose I'm a little bit worried about these powers, right? Because even powers, I can see there's something to do with even and odd from the question here, the options. I know that even powers are always positive. So if n is even, there are no solutions over here. But if n is odd, then I suppose I want cosine x to be -1. That happens when x is 180 degrees. So I think this is two solutions when n is even, because I get these ones on the left, but I don't pick I don't pick up any solutions on the right. And if n is odd, then I think it's 3 solutions. Is that one of the options? That is one of the options. That is option D. See if the live poll agrees with me. Live poll does. It's not unanimous. C got some votes as well. What's C? 3 for all n. I see how you get 3 for all n. You'd write down 1, 2, and then you get this third one for -1. Unfortunately, if n is an even number, then one of your solutions doesn't quite work, because it's -1 to n, which will give you +1, not -1. Half your solutions actually do negative sign in the middle. And I can sort of see how you would get B if you get these 2 roots on the left and you think that this thing is never 0, because those are the 2 kind of halves of this, right? If you mistake the odd and even numbers that way around. E is just the wrong way around, and A nobody's gone for at all. Okay, good. Pretty good. Okay. Any marks for guessing correctly? Alfie, great news. You get all the marks for guessing correctly on the multiple choice questions. Maybe that doesn't sound very good, but yeah, you get all the marks for guessing correctly. Multiple choice questions are marked correct or wrong, and you get 4 marks for the correct answer and no marks for wrong answer. You get no marks for leaving it blank. Right. For some reason, I'm learning about this one particular mathematician in chat. Good. Okay. 3 solutions. Answer is D. Let's throw another one at you. It's 7 minutes past 6. So we're doing all right, but I'm sure people are going to be off in a mo. So let's have a look at this one. This picture shows the unit circle, which mixed opinions in chat. I think some people seem very keen on the unit circle before. They wanted to explain that 180 degree thing in terms of the unit circle. Here's a unit circle. And it's been labelled with letters, so I'm getting the sort of flashbacks to trying to label the CAST diagram. But luckily it's not CAST here, is it? Or maybe it is. Maybe CAST will help us. Goodness me. Someone's joining from the beach. This is very exciting. Right, okay. There's a comment here that I want to read out. Ben's giving me some insight into their approach. Reading it now, cos nx equals 1. Yeah, it's a different question, isn't it? If it's cos nx equals 1, I mean, obviously it's a different question, but it's got a different answer in quite an interesting way, because powers giving you 1 is quite different from powers giving you -1. Odd and even powers can produce the number 1, but odd and even powers can't all produce the number -1. What is the answer if it's cos the nx minus cos the 2nx? I suppose you get all the 0 solutions. So you get the ones where cos x is 0, and then you also get the ones where cos x is equal to 1, which happens at 0 regardless. So maybe it's always 3 in that case. You chose C. Well, I don't know. Okay, maybe I'm wrong. Okay, so this question is a bit tough. It's a bit harder than the other 2 we've looked at. We're given this sort of double inequality thing, tan x less than cos x less than sin x, and there's some region of the world where that's true. There's a hint I've put down there to think about when these inequalities switch around. So cos x and sin x, they both change. Sometimes one's bigger, sometimes the other's bigger. Maybe we could think about the points where sin x is equal to cosine x. Is that easy? I'm not sure that's easy. Let's have a quick think. So sin x equals cosine x. So that would say that what I'm thinking is adjacent and opposite would both be equal. So this would be the 1, 1, root 2 triangle, I suppose. So this is one example of an angle that works. So that happens at 45 degrees. And then I suppose if I add 180 degrees, it also happens again at 225 degrees, because both of those things just go negative when I flip them around. Oh yeah, poll. Do you want a poll? Harriet would like graphs. Yeah, I think it's good. I think graphs is probably a good idea. Oh my goodness, the cast. There's a vote in chat as well for the cast from Rebel. Sorry, I delayed turning the poll on because I like seeing people say things in chat. Chat still runs when the poll's going, it just doesn't display on the screen. And I worry a bit that it starts to look like I'm stealing people's ideas, because I can read them off my console, but there we go. Right. And I don't want to look like I'm plagiarising people's ideas. Okay, I've discovered that sine x is equal to cosine x at 45 degrees. Maybe that's not helpful. It tells me maybe there's something's going on at 315 degrees, which is all the way around here, I think, kind of here-ish. But tan x, I haven't thought about that yet, so maybe that's not helpful. Maybe this is a terrible idea. I'm sort of leaning towards doing graphs, actually. Let me know in chat if you also want to do graphs or something like that. Different ideas. Oh, there are different ideas in chat. I will steal one of them in a moment. First, I'm going to draw some graphs. Drawing graphs is sort of a good way to get other bits of my brain involved, I suppose. So cosine x, I see cosine x starts off really big. That's 1. It's much bigger than sine x. So to start off with, we're doomed. We get up to 45, and then we've got a bit over here, haven't we, where cosine comes down to 0. So it's looking pretty good. Cosine is less than sine x. And that's actually going to keep going until we get around to 180 degrees. Cosine is still less than sine over here. And then I see, aha, over here, they cross over, don't they? So coming up round here, this is sine. This is cos. Coming up to here, cosine will be 0, and then it goes up, and sine will come to 0. So I see there's some bit over here where this second inequality is true between 45 and 315. That's the bit where I'm interested. So kind of A and E are right out. Not okay. Raphael's done a graph. Carter's done a graph. Anonymous says graph. Control y equals x on there. Maybe y equals x is good. What do I know? Hang on, I don't want y equals x, do I? Because y equals x is... I don't need the values to be equal to their inputs. Y equals x goes up here. Not so sure about that. Interesting question, when is cosine x equal to x? But hey. I said I was going to steal something else, but no, graphs seem to be quite positive. Graphs seem to be quite popular. Oh, someone says they all have to be positive. Is that true? Goodness me. They all have to be positive is an opinion you can have. I think they can be negative. I think the inequalities would still... You can have inequalities with negative numbers, can't you? It's not obvious to me that they all have to be positive anyway. Why 315, not 225? Because I'm an idiot. I can't talk right. I probably mean 225. If I said 315 at some point, I mean 225. Unless I don't. Maybe I don't. No, I do. It's been a long day, chat. It's been a long day. Right. Instruction from chat. I mean, instruction in no uncertain terms by Cartan here to go back and sketch tan and cosine, because we need to think about that other inequality. I'm starting to wish I picked nicer questions for myself here, or done them in advance. Maybe this is like a sort of advert. Do your questions in advance, chat. Okay, so cosine starts. Let's do cosine a different colour this time. Starts bigger than tan, but it will come down because cosine is going to go through 0 at that point there, where tan is excitingly going through infinity, and then cosine will come out on this side. Tan's now very, very negative, and then it will go down, and then it will go up again, and I'm a bit worried about that. Do I need to be worried about that? No, because there's another point where cosine's 0, and cosine comes out here. I was a bit worried about this section over here, but I didn't need to worry. Okay, so where is cosine bigger than tan? It's bigger to start off with over here, out to question mark degrees, and then it's bigger from 90 onwards up to, I don't know where that is, something else, and and then it's bigger from, let's be really careful, it's bigger over here as well. It's bigger from, what is that, 315 upwards? Up to 360? That last 45 degrees? Or is that the last 90 degrees? I'm so sorry, that's 270, isn't it? Cue chat telling me it's 270. And think about these. Yep. Okay. So this is not too bad. I think this is all right. I'm trying to piece everything together now, I think, because we've seen that the second inequality was satisfied from here upwards, but the first one, this tan x minus cosine x one, that one is only satisfied from some point up to 90, which includes this region over here. So I quite like that. And then it is true again from some other bit. Was it only true after 90? Oh, am I just wrong? Yeah, it's not true. It's true from 90 upwards. Can't read my own graph. True from 90 upwards. So from 90 upwards. Okay, so it's true initially for some start bit, but maybe only up to here or something. And then it was true from 90 onwards, which is also still while this one's true, because cos less than sine one. And then it stops at some mystery angle over here, which I haven't calculated. And then it keeps going round until later on at D. What's this? This is 180. Oh no, at that point it's terrible. It's not true over there. So I think my answer is C. Harriet Watt did all sketches on the same axes, which is probably a good idea. Do I measure angles clockwise or anti-clockwise? I measure angles anti-clockwise, but also see earlier, I don't know what direction clocks go. Chat is a bit divided. Oh no, you're not divided at all. You're 92% on C. It's pretty solid voting for C over there, chat. Oh, I see. Does it matter for this? It matters for this, doesn't it? So for this question, I guess you have to know that the angles are going up this way. 0, 45 around that way, anti-clockwise from the x-axis. Do you have to know that, or does that come from the fact that the coordinates are cos x sin x? So yeah, no, that comes from the fact that those are the coordinates, I think. With the arrows like this on the axes, I think it works out. Slightly unusual to have labelled them like that, but I think it works. Can we have coloured pens? Yeah, I think so. Angles on the unit circle. So the angle is x. Maybe that's something I sort of took for granted, that the angle is x. But it really is. This is sort of the angle x going around from the positive x-axis. That's the kind of normal way of doing angles. But maybe I shouldn't have taken it for granted that it was the normal way of doing angles in this question. Questions can be weird. So I suppose a way to justify that is to say, well, hang on, we've been told that a point has got coordinates cosine and sine. That matches up exactly with what we'd expect for this angle to be x, because then there'd be cos x and this would be sine x. Since we're on the unit circle, where things are radius 1 away from the origin. Denim has linked me to a Desmos plot, which I'm just going to check to make sure it's not some sort of... Ooh! I'm approving that. There we go. I can't remember which questions this is doing. Is it giving me a range? Oh! It's doing a range geometrically. Oh, this is quite nice. Can I show you this on the stream? I'm showing this on the stream. I think I know what this is doing. Okay, here's a Desmos approach from Denim. Thanks, Denim. You can't use Desmos in the test, but hey. X squared plus y squared equals 1 is the unit circle. And then the blue bit is y bigger than x. That's where sine is bigger than cosine. And then this green bit is where cosine is bigger than tan, I think, because tan is y over x. So that gives us some other regions. And there's this overlap region between 1 and somewhere over here, which is option C, which is quite nice. That's the only bit inside both green and blue regions on the unit circle. I'm interested in this other bit over here. up in the top right. Thank you, Denim. There is a link to Denim's picture on screen and in the Slido chat. Cool, right. Ben B wants to just try some of the values. Go for it. It's like trying values of n in the previous one. You could think of it like a circle. I mean, yeah, there's a circle in this question. Good use. I like these shading regions. Very nice. Good. Someone anonymous says that I should give Denim an offer right now. And what I like to imagine is that's like Denim's auto count or something, just like Denim switching to anonymous. I think we should give Denim an offer right now. Not how this works. In case anyone's thinking that's how this works. Nothing on the MAT livestream is part of the admissions process. That would be too stressful for all of us. And also because you've seen the amount of mistakes that I'm making at 6 PM on a Thursday in a live stream. Right, good. What did we pick as the answer for in the end? I think we picked C. Good. So we got A, D, C as our solutions for this week. Someone will tell me in chat if I'm wrong. Brilliant. Nice progress. What did we learn there? We didn't talk about what that angle actually was. I kind of avoided it. I didn't use the hint, which I wrote. That was a bit terrible of me, I suppose, to avoid the hint that I came up with. I think this triangle is interesting, by the way. This is a bit of a James Monroe tangent, but I think this triangle's cool. The one where tan x equals cosine x. Let's try and draw it. So tan x says that let's try and label it. Let's call tan x equal to, I don't know, let's pick some sort of symbol for it or something. Let's not pick that one. Let's pick this one. So then maybe I'll label my triangle up like this to say that tan x is u and 1 on the sides. Then, well, so I know from Pythagoras that the thing over here is root u squared plus 1. But I also know from the fact about cosine here that that's supposed to be equal to adjacent over the hypotenuse is supposed to be cos x, which is also equal to u. So that's adjacent over hypotenuse. 1 over root u squared plus 1 is supposed to be equal to u. I think that's kind of cool. I think you can rearrange this equation and solve it, and it's a quadratic secretly or something. Not totally convinced actually. I think it might have gone weird on me. May have done something wrong. Interviews assume pretty much the same knowledge as math. It's easier in interviews to work with mathematics because if you don't understand the maths, you can ask for help. Everyone asks for help at some point, I think. So we can rephrase things and make it a little bit better. It means that we can ask using random bits of mathematics and it still works. Yeah, there's a golden ratio hidden in here, isn't there? That's why I put a phi in, but then I got cold feet and I scribbled out my phi and write u. Opposite over adjacent is tan. Adjacent over hypotenuse. What am I doing wrong? Maybe I'm not doing anything wrong. Maybe this is just completely correct. Oh yeah, this is completely correct. Pauses in indecision. Ah yeah, there's the hidden golden ratio, but it's a golden ratio of, what is the square root of the golden ratio or something. Homework. How big is golden ratio minus 1? Ben's got a solution. So that's pretty good. This triangle also comes up in a more recent math question. I just think it's neat. Good. Do also give cash prizes? So I think some of the colleges have got some prizes. It's a bit complicated. It's not why the students are in it, I suppose. Is it pronounced MAT or M-A-T? I do both. I say MAT the first time, and then if people are giving me blank looks, I start spelling it out. And then if people still look confused, I say mathematics admissions test. But I say that exactly once at most because it's long. Yeah, it's the square root of phi or something. I got really cold feet solving that. I'm going to go back and solve it. No, you know, face up to your fears. Scary equation. I'm sort of scared that it'll be a quartic equation, but it's not. It's a quadratic equation. It's a sort of hidden secret equation. If I write W for u squared, then maybe I'm not so scared of this anymore. You just don't. The puns that go through my head that we don't do. if you think the puns that we do are bad, then the puns we don't do are even worse. W over here, and I'm still sort of feeling kind of bad, but no, I do want to write this down. I think b squared minus 4ac. It's been a long day, chat. It's been a long day. Is it something like that? And then I want the square root of that. So I probably want the positive root. Something like that. Yeah, may have dropped some plus or minus signs along the way, but I'm sort of happy. Tried to square it and rearrange. Yeah, good. Okay. Who was the most prodigious student you interviewed, taught, or admitted? If any of my current students are watching, then no offence. But I think all of my students are too young to have become really prodigious yet. Yeah. This is related to the golden ratio. This is pretty similar to the stuff you might write down if you're doing golden ratio sort of questions. W is u squared, so I want the positive one, which is, I think, the one I've written down. Good. And then square root it. Yeah, it really feels like the sort of thing I make mistakes on, so I'm going to move on really quickly. Before people point out all my mistakes. Here's a long mat question. Are we ready? We're going to do a long mat question? I think we're going to do a long mat question. Oh my goodness. Whew, just saw the view count, there's a lot of people. W is double, therefore 2u. Yes, very funny. Right, sorry. Right, good. Here's a long mat question. Long mat questions, you get marks for your working out along the way. There are marks out of 15 overall. They're marked by graduate students. You should show your working. You should use words if you can. The parts normally have Roman letters down the side for part I, part II. They seem to have broken on this one I've got on screen, but the questions are normally numbered with Roman part numbers. They can ask you to sketch graphs. They can ask you to do little pictures. You answer them in the booklet, so there's some pages in there. You're not supposed to use extra bits of blank paper. You're supposed to answer in the booklet. So that's something that might happen here. Indeed, this first part of the question here wants us to sketch a graph of a plus x over a minus x between minus a and a. So that's something you can try on a scrap bit of paper if you're playing along at home. Yeah, Jack really got me there because I was so primed to think about mistakes that I might have made. I'm doing math computer science. Oh yeah, this is a maths person question. It's a Q4. If you're applying for maths and computer science, then you don't do question 4 on the mat. But you might still learn something by trying it now. Haven't applied yet. So you don't get to ignore it. I should use Desmos for this. I can't use Desmos. It's question 3 maths only. Question 3 is done by maths and computer science applicants as well. I will draw the table. While you're thinking about drawing this graph at home, I will draw a quick table of which questions people do, depending on whether they're applying for. It's not a table, I lied. Depending on which of the Oxford courses they're applying to. Computer science, you skip both of those and you go and do 1, 2, 5, 6, 7 like that. If you're applying for maths and stats, you do the same questions as maths people. If you're applying for maths and philosophy, you do the same questions as maths people. If you're applying for computer science and philosophy, you do the same things as computer scientists. Essentially 1, 2 and 5 there are everyone. 3 and 4 are maths questions. And 6 and 7 are computer science questions. What am I saying? Why am I talking like this? And then the maths computer scientists do 3 and 6, one of each of those things. Good. Yeah, different approaches. I would probably just go for it and do something like Cartan's saying about finding this asymptote when x is equal to a. Graph gets really big when x is really close to a. When x gets close to minus a, this is just 0 divided by 2a, so it's going to go through 0 over there. And then I think I would think carefully about when x is getting very close to a, but it's slightly less than a minus x on the bottom there, that would be positive. So I think this is very, very positive up here. And then I think I'm almost done, because I think we've almost also got almost everything else. Oh, I suppose, yeah, when x is 0. When x is 0, you can plug that in and you get your number 1 or something. And then I think I'm just going to join the dots. Yep. There's a person here trying to write a very consistent personal statement. I think it's possible to write a personal statement that kind of can be interpreted in different ways for different courses. Definitely I've seen people apply with a personal statement that talks about maths and physics, and that's fine with us. People talking about maths and philosophy and computer science all at once. You're allowed to have other interests. You're allowed to be applying for other courses at other universities. We don't actually technically get told you've applied for other courses at other universities, but we don't not really that interested either. This graph that we're sketching is going to be a bit like a 1/x curve, but translated around a bit. Right, join the dots time. Let's go. So from 0 up to 1, and then steeper and steeper and steeper, up to infinity, but not beyond. Oh, and I've cheekily sketched a little bit beyond A as well, because I've done for free. Good. Okay. There's a graph sketch. Thing about the long questions is that you can get some marks like this. This bit we've done so far is like quite an easy short question. It's quite an easy multiple choice question. I mean, it's not a multiple choice question. It's a graph sketch, which we've sketched it. I reckon we've got 1 or 2 marks from just doing that. Even if we stop now, 6:30. So if you want to go, have a nice evening. This stream will be available to watch anytime afterwards. But if you stop now, you've got a couple of marks. Better than nothing. Good. Okay, but we can look at the other parts of the question as well. We're going to go and do those. I'm going to put one on the screen for people who are playing along live, and answer a couple of questions from chat that have come in. You feel free to mute me if you don't want to hear the answers to the questions. Somebody says my personal statement is really impressive. I'm not sure I agree. I don't think my personal statement is very good. I think it's over enthusiastic and a bit show offy. But that's fine, isn't it? Mine isn't, but the rest of my application is okay. Do I still have a chance? Yeah, so I put my personal statement up on the internet, and it wasn't supposed to scare people off. Although the thing I can't help is that it was written by 18-year-old me, 17-year-old me, who is just not very socially capable. So it's written in quite a show-offy way. You don't have to be 17-year-old me, and I would probably not encourage anybody to be 17-year-old me. Like, I was kind of a jerk. So yeah, your personal statement doesn't have to be like mine. I'm not sure I made it clear enough in the video that I think my personal statement was written by a jerk. I know it was written by a jerk. It was written by 17-year-old me. So yeah, maybe at some point we'll do a James reacts to James Reed's personal statement. We've already done James Reed's personal statement. The logical conclusion is James reacts to. How do I link maths and languages? Probably via some sort of linguistics. I don't know. Some kind of linguistic thing, maybe, if you're interested in that. I don't know. Up to you. If they're your interests, then see if you can think of something that you're interested in both of them, or just talk about both. There are 4 marks for each multiple choice question. You do 10 multiple choice questions to get 40 marks, and there are 4 long questions that you do. They're worth 15 marks each, so you get 60 on the long questions, 40 on the short questions. Why do Oxford, so there's a question all the way down here, why do Oxford choose to have a much easier test than STEP? We're trying to get it out of the way early in the process, so that people apply, they do our test, we consider applications, and then we make our kind of final decisions in January. STEP is taken much later on. Why not do it at the same time and just to make it harder? So we don't think people have learnt enough mathematics at the time of the MAT to do a test that's like the STEP. We think people are applying midway through school. So yeah. Can you do a pure maths at Oxford without doing any applied maths? No, you have to do a little bit of applied maths. Especially in first year, you do a bit of applied maths. Sorry, I'm going to teach it to you. You probably, it's probably not quite what you're expecting. People in chat, Raphael's got a suggestion of a linguistics languagey kind of thing that's also mathsy. Has there ever been a perfect maths score? Yes. Can you talk about lots of different things? Personal statements. Next natural step is to roast your personal statement, says Carl. Wow, goodness. I'd quite like to see Gauss's personal statement, because Gauss is one of those mathematicians who famously did loads of stuff while they were really young, so that'll put us all in our places, right? Somebody should, as a joke, think about all the things that Gauss did before age 18 and then write that personal... No, don't you? Okay, right. That's not gonna... It's one of those ideas that sounds funny and then it doesn't turn out to actually be funny when you do it. Do we do error code forwards? Yes, although we try and write the question so that there's not too much error code forwards needed. Harriet's got a good comment about analytical skills. This is why I like having people along. Raphael and Harriet both give really good answers. I didn't really answer the question at all. Does your third A-level have to be maths related? No. It can be any A-level except general studies, which I think is not even a thing anymore. Can a really good maths score compensate for a personal statement? Yep. Absolutely. Good, right. Let's do a math question to compensate for our personal statements or something. Oh, goodness me. Everyone's personal statements are usually fine. They're usually good. People tell us that they're interested in maths, and you look at it and you think, oh, this person's interested in maths. Oh, their maths score's pretty good. Great. Let's do this math question. Maths score is more important than personal statement for Oxford applications because it's maths. We're given a shaded region. It's the points between minus cosine theta and sine theta. And the region B is the remainder of the half disk, which, yeah, okay, is those bits over there. It's sort of two regions, isn't it? Or are we considering one region to be disconnected region, maybe? Slightly odd, we've been told that these things are in terms of theta, some variable, but we haven't been given an angle theta. Your fifth A-level is a joke in chat here. You want a classics and maths course. Let's draw some triangles. I'm not going to go for a 1 to 10 scale because a 1 to 10 scale will just get quoted out of context, and then people would be like, Oxford told me that the personal statement was worth 3i out of 10. Good. Right, let's draw some triangles. I agree with the triangles because I kind of want to find this angle theta. We've got these triangles, I guess, here where this is radius 1 because it's a circle. Well, it's half a circle, but come on. That's a right angle. So then I've got a triangle over here. That's minus cosine theta. I think this is theta. I'm a little bit worried there might be... No, that is theta, isn't it? So then the x-coordinate is negative cos theta, but that angle is sine theta. And then this side over here, I guess, is sine theta. I want to do the same thing over here. Except this is not theta anymore, because then it would be cos theta on the x-axis. And it's actually sine theta, so I think this is theta up here. This is sine theta opposite over hypotenuse, and then this bit over here is cos theta, which is a bit weird. That's a bit weird. Drawing in these lines felt natural, I suppose, because I could see a right angle. I wanted a triangle. I know something about the radius. Joining things in. Personal statement was posted a couple of years ago. It's on this YouTube channel. If you scroll all the way back in this YouTube channel in uploaded videos, there's something up there. I don't even link to it anymore because I think it's too cringe. If you were in charge of admissions at a non-Oxford university, how would you do it with no admissions test or interview? Goodness, depends which university. You'd probably use A-levels. Good, right. Oh, Abel's got a thing. It's an answer for this question, which reminds me that I should be doing this question rather than thinking about personal statements. I've got some triangle facts for you. That's 90 degrees minus theta. So I suppose this turns out to be 90 degrees. There's a right angle. That's pretty nice. Angles. Cool. What does that mean? That means the area of A is two triangles that are 1/2 sine theta, cosine theta each, plus 1/4 of a circle. 1/4 of a circle of radius 1. Pi times 1 squared over 4, which is, I guess that's pi over 4 plus sine theta cos theta. Okay, good. How do I know it's a right angle? Yeah, well, I got spoiled a bit because Alvor has told me in chat that there was a pi by 4, so I was already thinking about 1/4 of a circle. But the way I think you could discover it is by labelling this angle as theta to make sense of this cos theta down here. By labelling this angle as theta to make sense of this sine theta over here, with 1s on the hypotenuse, and then following some angles around. There's a theta in here, so there's a 90 minus theta over here. This is a straight line, so the angles must add up to 180 degrees. We've got theta, we've got a minus theta, so that's fine. We've got a 90 degrees, we need 90 more degrees. So this left over bit must be 90, it's a right angle. There's probably a way to do this by thinking about the equations of the lines, which sounds mad, but it's probably only a bit mad. To think about this line that I've drawn as y equals kx and this line is y equals mx, and then to prove that kx and mx are at right angles to each other. I kind of regret saying that, but you know, whatever. Good. Do we need the area of B as well? I don't think we do, but Cartan, you're correct. The area of B, since these things add up to pi by 2, it's going to be pi by 4 minus sine theta cos theta. I'm doing some subtraction in my head. Wow, and reading off chat. Does it matter where you take the A-levels? No, an A-level is an A-level. Good. Okay. Looks nice. Part 3, and let's change that to part 4. I'm going to give you a motor to do part 3. Part 3 here is the part that we did some foreshadowing for before, by thinking about the relationship between sine squared cos squared and sine theta cos theta. We had a warm-up question that used those skills. It's going to be relevant to this question because there's a sine theta cos theta in this question already. We're going to do some sort of inequality stuff. Hint for this part, we're not really assuming only that sine squared plus cos squared is 1. We're also assuming that we know how to square things and we know how multiplication works. We're assuming a lot of things, really. We're assuming that if we know one thing, we know that thing implies something else, then we're allowed to deduce the second thing. Private school, our admissions policy is more complicated than just private school, state school. I know that statistic gets reported a lot in the news, but we know it's more subtle than private school, state school. There's a lot of variation within state schools, and there's a lot of variation within private schools as well. Where we assume stuff, no, we get some information about your application that's more specific than just school type, for schools in England at least. Good. Do we do deferred entry? Yes, we do. Some colleges prefer you not to do deferred entry and prefer you to apply during your gap year. Some colleges consider both. Check with the admissions office at the college that you're applying to. Please don't email all the colleges. Check with the admissions office at your favourite college, and they will probably say go for it, or they might say please apply next year during your gap year. Good. Those are the two ways of doing a gap year. Make sure you keep your math skills sharp during your gap year or year out, whatever you're doing. Gauss, you're like 200, right? But there's actually no maximum age for applying to Oxford. For people over 21, we'll look at your most recent 3 years of what have you been up to. Maybe do something recently. I can't believe I'm telling Gauss to do something recently. Someone's being a quantitative analyst at Goldman Sachs during their gap year. So whether or not it's impressive, they're hopefully getting paid. Goodness me, haven't heard that one before. Right, it's very similar to the warm-up question, isn't it? I maybe made the warm-up question too similar, but let's go. So the thing that I would like to do is to think about sine theta plus cos theta, and square it, and that's equal to sine squared theta plus 2 sine theta cos theta plus cos squared theta, which is equal to 1 plus 2 sine theta cos theta. Aha, which is brilliant because it's 1 plus 2 times the thing that I'm interested in. But I also know that it is bigger than or equal to 0 because it's a square. I purposefully squared a thing so that it would give me this sine squared cos squared stuff, but also so that I could say that it's bigger than or equal to 0. Aha, this is great news. This tells me that sine theta cos theta is greater than or equal to minus what? Oh, okay, right, that's not quite what I wanted, right? So if I rearrange it, I subtract the 1, divide by 2, and I've proved that sine theta cos theta is bigger than minus 1/2. So it's probably not, that's not quite what I wanted. I want to show it as less than 1/2. Can I think about the minus sign somehow, do some cast stuff? Goodness knows. Oh dear. Why didn't I go into investment banking? Because I wanted to do this. Here we are. I want to show you an important skill, actually. You wouldn't know it, but I've made this mistake on purpose. It's in the extension as well, if you don't believe me. Quite often when you're trying to prove something, which is what we're doing when we're trying to show that, is that you want to go out and just write down true facts. If you can see all the way through to the end point, then that's great. You're very talented and you'll be doing just fine at everything you try, I suppose. But sometimes you can't see all the way through to the end goal, in which case you'll need to just write down true things and try and fumble around exploring through the jungle, where you can't see past all the trees, and you have to keep exploring until you get to something that looks like your final destination. And when you're doing that kind of exploring, fumbling around, you're going to end up in some other places along the way. It's not going to be the same as just walking a direct route to your destination. So you need to be able to backtrack a little bit and adjust what you were doing. I'm liking this jungle analogy, which is coming up live. So being able to switch up what you were doing before is a good skill to have, especially if it involves not starting again. People in chat have got great suggestions of how to fix this. You've already done the step that I want to try and demonstrate, where you backtrack a bit and work out what you can change. So I could throw this away and start again, but what I actually want is to notice that it hasn't gone terribly. It's fine up to some sort of minus sign. So first I should go back through my work and check that I didn't miss any minus signs when I was multiplying out or something. I think there aren't any minus signs at all. That's sort of the problem. So if I look back, I can't see any minus signs. I can read my own handwriting. Sorry if you can't read my handwriting, but I can read my own handwriting, so I can go back and check my working. Yeah, I definitely didn't miss any minus signs. But actually that's giving me the idea that maybe if there was a minus sign, then where would I want it? I would want it kind of here, so I want it kind of here, so I'd want it here, I suppose. And that's got close enough for me to realise that if I had a minus sign over here, then I would end up with a minus sign in the right place. So I've backtracked to have an idea and to change something. I'm going to explore that way and see where it goes. So I've got to make all this true. This thing, I put a minus sign in, so when I multiply it out, I get a minus sign. So when I rearrange it and simplify it, sine squared plus cos squared is still 1, but I'll get a minus sign over here. This is still positive, because I just changed stuff inside the brackets, and squares are still positive. But now I'm going to subtract the 1 and divide by minus 2. Dividing by minus 2 will flip the inequality, and it will importantly give me that extra minus sign in there as well. And that will give me the thing that I want. So now I've found my way through to the target that I was going for, but along a kind of branching path where I had to backtrack and come the right way again. Thank you, chat. People going for it. Brilliant stuff. There's a maximum fact in there as well. Yeah, okay, good. Other approaches as well. I'm not too excited about other approaches because I think this is one of the times where they're trying to tell us to do it a certain way. It really feels like they're trying to tell us to use this sine squared plus cos squared fact. If the question's kind of telling you to do a certain thing, then it's sort of an instruction to do a question in a particular way. I hope that was helpful. It was slightly fake. I mean, it was more than slightly fake, but trying to make a helpful kind of mistake. It wasn't even a mistake because it was all true, but never mind. Magic squares in chat. Look at the product. Cartan, how do you know that the product is biggest at 45 degrees? It's not obvious that sine cos is biggest at 45 degrees. I think it's true, but not obvious. I think it depends what you actually write, whether I give you marks for that. I think this is the last part of the question, by the way. Let me just check. Yes, it is. Last part of the question. We're almost there. 10 to 7. What's the largest value? And I think this is supposed to link everything together in the question. The area of A divided by area of B. Aha, this is why Cartan told me the area of B earlier on. we've got expressions for these things. I am a big fan of writing all over the questions and just copying things out like that. You do get, on the actual mat, you get some blank pages to write your answer on. You don't have to write your answer all over the questions like I'm doing. If we do something like this, then I think one approach is that it starts to look like the very first part of the question. Number plus variable, number minus variable in a fraction. Number plus variable, number minus variable. If you kind of squint, it looks a little bit like that. Actually, I think the most direct way is to just say, well, A and B, they add up to a semicircle. I can make this big by just making A big. This isn't a show that question. I just want to get to the answer. I want to make A big. That will also make B small. That's good news for my fraction in two different ways. Big on the top of the fraction, small on the bottom of the fraction. I've forgotten which way around numerator and denominator are. As I say that, I remember. Big on the numerator, small on the denominator. That's how you make a fraction large, which I can do just by making sine theta cos theta large. How am I going to do that? Well, I'll need to think about sine theta cos theta. That means make sine theta cos theta large. And that's part 3 of the question. We know that sine theta cos theta is, the biggest we can make it is 1/2. If we make it 1/2, then we get the area is pi over 4 plus 1/2 over pi over 4 minus 1/2. That happens at 45 degrees. But could be simplified, probably not too important. I've been told about sort of magic square, which I will go and learn about after the live stream. Is it octonions? Oh no, it's a diagram with octonions in it. Oh, it's very complicated. Right, good. Substitute for negative theta. Oh, substitute for negative theta in my. So I got down to sine theta cos theta is bigger than, so my kind of dead end, maybe not so dead. So substitute theta goes to minus theta. So this is true for all theta, so we're allowed to relabel it to express it as being true for all negative theta as well. Whether or not it's positive or negative, confusingly. Yeah, that works, because then you get a minus sign from the sign, and multiplying by -1 flips the identity. Yeah, that's more direct. I like it. Substitution for negative theta. Verified, does work. How did I find the area of B? Well, I know the areas add up to make pi by 2, because it's a semicircle. We had A, so I just did pi by 2 minus the thing that I have for A. I did it quite fast. The thing about using the graphics tablet is that it's slightly slow to write things down. I did that in my head. That's what that is. I said that like it was something to be proud of, but subtracting. Yeah, something like that, right? Pi plus 2 over pi minus 2. Good. How do I get sine theta times cos theta? Well, I wanted to make... Oh, where? Which stage? Anonymous person who wants to know, how did you get sine theta times cos theta? Where, in the last part? In the last part is because I know that the area of A is pi over 4 plus sine theta cos theta, which I can make that big just by making sine theta cos theta big. And that was the same thing that was in part 3, where it came from doing some squaring. Someone was looking for Oxford lecture notes suggestions. So if the Oxford lecture notes are just online, we put them just publicly online for our students, in case anybody else is interested. I think if you look at introductory calculus, there's some stuff in there which does some revision of A-level material, and goes slightly further as well, and does some new things. So if you want a course if you want to look at some lecture notes of something interesting that's a kind of on-ramp, you might have to look at. The lecture notes, maybe someone helpful will link to the lecture notes in chat for me. They're just publicly out there. I don't really recommend that people try and learn Oxford courses before going to university, because it's a load of work, and when you go to university you learn it again anyway, so it's sort of a waste of time. But Okay. There's a question, what graphics tablet am I using? I'm using a cheap graphics tablet that I got on Amazon. The brand is Veek, which is spelt with 2 Ks. It was affordable, let's just say affordable. Affordable sounds more sophisticated than saying cheap, right? Nameless says, why can I substitute for minus theta? Well, I can substitute, this is maybe an important point, I can substitute for anything I like. So over here, if I know that this is true for all theta, this is maybe a power you don't know you have. This is true for all theta, for any number you can think of. So it's also true that you could write down sine of x, cos of x is bigger than or equal to minus 1/2 for all x. If you invent your own symbols, it's still true, whatever you like. You can put in functions in here because anything that returns a number will just be some number, right? F of x will give me back some number, and then sine of that, cos of that will be greater than or equal to minus 1/2. The function we've picked is the kind of quite simple function, minus x, sine of minus x, cos of minus x. These are just numbers that I've put into in sine and cosine shape. So it's still bigger than or equal to minus 1/2, but then we know some facts about sine of minus x and cos of minus x, which we've then used to bring out a minus sign and flip some inequalities around. If this freaks you out and looks weird, that we're swapping an x for a minus x, and I've got this kind of theta goes to minus theta stuff, practice this a little bit, because being able to do this quickly is quite a good skill to have. If you prefer to go via a different variable, so if you prefer to go theta and then replace them all with x's and then replace the x's with minus thetas, then that's okay, but you might want to practice the speedy method. I have done that way too fast. Sorry everyone, that's like 2 or 3 lines of working probably. Done it too fast on the board. Why is the maths on the physics test so easy? They have to be good at physics as well. Euclidean geometry. When in doubt, draw right-angled triangles. Fair enough. Is PhysPhil? I don't know very much about physics and philosophy at all, sorry. Is it harder than math, Phil? No idea. I mean, it's worth 1 degree. Do I know about Dexter's notes? No, sorry. I think I know what that's going to be. So very quickly. Oh no! Oh, it's a lecture video. It's a lecture video. Right, cool. Here's the YouTube link. As well as the lecture notes, we also recorded one of them as a YouTube video. It's on the main channel. This is Oxford Mathematics Plus. If you find the Oxford Mathematics main channel, oh my goodness, it's got 8 million views. The YouTube algorithm loved this one. So if you want to see one of the lectures, with you and 8 million of your closest friends, can watch that over there. YouTube is such a strange place, and I know I'm saying that on YouTube right now. What's a decent mark on this test? Card has a decent mark on this question for a first attempt at the MAT long question. If your first ever MAT long question, you should be pleased that you could do some of it. You could be very pleased if you could do all of it. Number mark doesn't really matter, because the number mark depends a little bit on how many marks you're going to be given for your show that here. How convincing are you? You quite convincing? Did you write some words? I've been bad. I've written no words. I'm going to add in, we know that. Adding in words is a good idea because it explains what's true, because x squared is bigger than or equal to 0. So there we go. Putting words in explains what you're doing. 12 out of 15 would be pretty good. I'd be happy with a 12 out of 15. Good. Any topics? Okay, right. We're petering out because we're running out of math questions. It's almost 7 o'clock as well. The extension is differentiating cosine and sine. If you don't know about this, don't worry about this. This is absolutely not maths. There's this slightly cool thing going on with cosine and sine. When you differentiate them, there's this nice pattern that you get, which is also present in a different bit of maths if you know about complex numbers, and it's all related. Loads of these things. I had to put something in because a bunch of the things on the maths syllabus that look very different are actually related together. They're basically the same thing. All the trigonometry and the exponentials are basically the same thing. The differentiation stuff kind of related to a bunch of these things. Later on in university, they turn out to be very similar things, and that then happens on a bigger scale with other bits of mathematics. This kind of coalescence of different ideas in mathematics turning out to be more or less the same thing is one of the fun things about learning more and more maths, that things that look very different turn out to be actually the same sort of idea of wearing different disguises. So that's good. Nobody actually links to the courses page, so maybe I will. This is my, there we go. Yeah, fine. There's a link to the courses.maths.ox.uk if you want to look at some lecture notes. Please don't feel that you have to try and study Oxford courses. Do you need an A star in AS physics to apply for maths? No, you don't need any grades in physics to apply for maths at Oxford. You don't need any ASs to apply for Oxford. Intro to Uni Maths. Oh yeah, have a look at Intro to Uni Maths. There's quite a lot of content in it, but it also sets out, I mean, it's one of the first courses that people do at Oxford for maths degree. Intro to Complex Numbers is there as well, which is just a couple of lectures. These are, they're at the start of the course for a reason. They're a sort of on-ramp. If you're about to apply, if you're in year 12 going into year 13, then this stuff is about a year away. So maybe ignore me talking about calculus just now because you haven't learnt it the first time yet. The introductory calculus course I quite like as a way to revise A-level, probably topics that you haven't learnt yet if you're going into year 13. To revise A-level maths and then learn some new things too, like partial differentiation. What is a Panopto folder? Panopto is a service we use for doing video hosting. So the Panopto folder is a folder of lecture recordings or videos. Would I think less if one of your A-levels is art? No, any A-level. So if you're doing maths, further maths and art, it's fine. What's your maths score? Genuinely more interested in how good you are at maths. I mean, don't take that the wrong way. I think it's great. I think it's a really good skill to have. You're not at a disadvantage to the people who are doing chemistry as their third one, or people who are doing physics as their third one, or people who are doing German as their third one, or something like that. Can the math field students choose applied maths or physics modules? I think that they can't, because the bit of math that's been switched out for philosophy content is the more applied side of mathematics. So I think it's hard, not impossible, really. I mean, nothing in this life is impossible, right? But not something we can advertise. Oh goodness, there's the advertising law. It's difficult for maths and philosophy students to do applied mathematics because they don't do the stuff at the first bit. Personal maths interests, dice, which is not really a maths interest. Dice problems, there's a load of cool stuff going on with probability. Generating functions are pretty great. Personal statement, see personal statement. My research was on fluid dynamics, solving the Navier-Stokes equations in a very, very particular case. Can't stress how particular. Solving Navier-Stokes equations in general, you win $1 million. Solving Navier-Stokes in one particular case, not so much. Maths at EPQ. Should I research a philosophical debate? So I never did a DPQ, and I'm not your advisor for your EPQ. I've heard that it's quite hard to do an EPQ in mathematics, because they're normally quite essay based, right? I mean, is that what the E stands for? Extended qualification. That said, maybe this is an idea that you find out some sort of philosophical debate, like you try and get into axiomatic set theory, or you try and find out about the axiom of choice, or you try and find out about infinity and cardinality and things like that. If you really want to, sort of fundamentals of calculus, but all that sounds quite hard. Maths and philosophy is tough, and I think I'm not sure if these are good ideas for something for you to spend a chunk of time on. Probably things that you could consider. I don't think it's inherently a bad idea. Good luck. Never did an EPQ. Sort of, wish that I'd maybe done EPQs. Sounds a little bit fun. How do I recommend getting started on fluid dynamics? It is tough because if you do it properly, in my opinion, you need a lot of vector calculus. So you would learn a whole bunch of vector calculus first, which sounds like quite off-putting, but it actually works the other way around for me. That I learned the vector calculus anyway because I loved the vector calculus, and then later on discovered that you could do fluid dynamics with it. I thought, that seems like a lot of fun. How do I apply to take the MAT? Strongly advise you check the admissions testing website, which I'm going to link to in reply to your comment. If I can find your comment. There we go. Found your comment, reply. That's right, info at admissions testing website link, admissionstesting.org. Short answer, you get your school or college or test centre to register you to do it. Good. Okay, I'm going to wrap up, I think, to go and get a train. Next week, I think it is geometry. I think so. So I'm not calculating the velocity of your tears, but if your tears merge together, if they drip and they merge together, then I can tell you something about that. I've got a solution to the Navier-Stokes equations. So knowing a solution to the Navier-Stokes equations is fine. The zero velocity vector field is a solution to the Navier-Stokes equations. Nobody gets $1 million for saying that zero is the solution to these equations. I mean, it satisfies both sides, right? You plug in u equals 0 on the left, u equals 0 on the right, there's no forcing. Oh, okay, let's solve the Navier-Stokes equations, mate. The solution, the question is actually very particular. And I'm actually slightly telling a lie by saying that you solve the Navier-Stokes equations. The question is not, please solve the Navier-Stokes equation. The question is about existence of smooth solutions. Right, see you next week. Thanks everyone. Take care. Oh, Agatha's interested in AI. That's a good philosophy question. Tell I'm not a philosopher, right? That my philosophy is very my take on philosophy is very logical, very sort of reasoning in that very reasoning, whereas there's also ethics, right? I didn't do anything about. Right, okay. Solve them generally. I don't think you have. In a nice way. Good. Ming, you can apply for maths and statistics. It's not actually more competitive. You don't actually need to be better at maths. We're looking for the same standard of mathematician on both the maths course and the maths and stats course. If you look at the admission statistics, you are looking at a fact about all of the people who apply for each of those courses. I'm not trying to throw shade at anyone in particular. Cool, right, on that note, I've got to actually stop. I can't do this. Best tip for improving problem solving skills: practice getting stuck on problems, practice getting unstuck on problems. There are probably questions I didn't answer as well. Yeah, I started a couple, I didn't do them. They're both about maths and philosophy, which is fine. I don't know huge about maths and philosophy. Right, cool. I actually need to go. Right, let's stop. Bye, everyone. How do I stop the live stream? Oh, goodness. Always chaos. Never not chaos.